Hey guys, welcome back to our channel. Today we're going to be talking about cyclic queue implementation using arrays. So in my last video also we did an implementation using arrays, but it had a limitation at the end. So if you guys haven't watched that, I highly recommend you to do that. So this is video where we come over with that that limitation that we faced on the array. So over here we have array elements, and this is our front and this is our rear. The rear is where we insert our elements, and the front is where we do the deletion of our elements. So the limitation that we faced in our last video was, for example, let's say we delete this one, or let's say first in and first out, so this one got removed. And whenever we remove it, we don't really remove it from our actual memory, we just move the pointer. So still the 3 is there in the memory, so it's not like, now after we do our front and then we delete this as well, we have only this. Okay, now as far as good, it's so good, you can like simply delete the entire queue and literally start over fresh and really start inserting elements again if your queue is empty. I've covered this in the last video. So if your queue is empty, then it's completely all right, you can insert your elements again and make them a newer one, because your front and rear are going to be resetted back. So your front is going to be -1 and your rear is going to be -1. So when you enter your queue, you reset your front and rear values, so you can go ahead and start inserting your values again. But what if, let's say, you got like this? You literally like inserted 10, 20, and 30, and this is your full array size. That's it. You cannot store more than the size of a 3. And now what you do is you do delete an element. Let's say you delete this for convenience. Let's have this as our front and this as our rear. Okay, now we're going to also remember that this is always going to be our front and rear, but just for a visualization part, I'm just changing the parts. But in array, you would have it at your 0 index and your first index and your second index, and your front would be pointing towards the 0th index, and your rear would be pointing towards the end of your array, because you do eliminate the ones that are on the start, and rear is just for inserting elements at the last. So that's why. Now coming on to back to this, this is just for convenience, so don't take it as a part of how this is actually stored. So yeah, and let's delete this element and move our front here. So our front just got from 0, 1, and 2 got to 1. Our front is currently 1, and our rear is currently 2. All right, so we got our front as 1 and our rear is 2. But let's say we're going to insert an element here, and whenever we do an insert an element, we insert it at the rear part. And what does the rear will tell now? The rear would do plus plus. No, it won't, because it has reached its size limit. So whenever it sees, oh my god, my rear is at almost all the full capacity, it wouldn't even do R++. So simply say my queue is full. But actually the queue has some space. But why is it not allowing us to enter the elements? Because we just move pointers and we don't delete those numbers from memory. Now let's go for the implementation part. So for a normal queue, we start at inserting elements at the 0th index, and then we go to the first index, and then the second index, and then the third index. Let's say the size of our array is just able to store 4 elements. We stop over here, and we can no longer insert elements because after 3 it's the end of our storage capacity. But what if you could go back and rewrite? So what if you could go back here and start inserting elements as you remove them? So this is actually simple. I'm going to show you how you can do that. So whenever our friend is pointing towards the first index, it indicates that we have deleted an element and our friend is no longer pointing to 0, meaning that this element is no longer in the queue. To stimulate that, we can actually go back and overwrite the element over here, whatever stays here. For example, let's say it's 10. You do want to insert another element, we can go ahead and insert it 20. So what we need to do, you need to, bring back your rear over here from this end to that end and try to insert an element. And this might seem like not a correct idea, but I would say this is honestly a good idea. And still rear is pointing towards, even though it's pointing towards the 0th index of the array, it's still pointing towards the last element. To be more clear, let's say I got 10, 20, and 30. Now this is the full capacity your queue can store. Now you delete the 10th element and you want to insert 40. Now if it's not a circular queue, you can't really do it. But as it is a circular queue, even though the memory is occupied by 10, it accesses the index over here and replaces it with 40. So once you got your element 40, this is going to be a last element because 20 was the one that came after 10, and then 30, and then 40 must be deleted at last because it is the element that came last. So rear will point over here. So let's start with implementation. First, plus circular queue, and after this, we're gonna have an integer array, and then we're gonna have front, and then we're gonna have rear, and then we're gonna have the size. Now I'm going to create circular queue, and then I'm gonna go and initialize the values for this circular queue. So in circular queue constructor, we need to get the size from the user. So whenever user is initializing a queue, they need to give the size as well. And then we're gonna go this dot size. Now for this, you don't need to have a capacity variable. In our last simple implementation using an array without a circular queue, you would need a capacity to actually check whether you have reached the end. After once you fill it, but this time you don't want that. So yeah, and we're initializing the size, and then front is equal to -1, and rear is equal to -1. Because if you delete an element and you got some free space over there, rear will just point over there, so you can just go ahead and insert an element there. So there's no need for a capacity now. Now let's just go ahead and start with the other functions that we need to do. So there are two check functions that you need to do. The first one would be isEmpty function, and then an isFull function. Now the isEmpty function, public boolean is empty, is empty. Now this is going to check if return it's going to return front equal to -1, so you know that okay, our queue is empty because our front is -1. So now you need to be really careful with this. Now isFull condition. If you remember in our last video, if our rear has reached about the size of the array, like it has reached like array.length minus 1, we would say that our queue was full. But this time you need to be quite different with this. To say our rear is full, because we only say our rear was full because you see we are doing a cyclic queue right now. So you would only want to say your rear is going to be full only when it is rear plus 1 size is equal to front. Okay. Now this might be feeling a little bit confusing, but we're going to go through this one as well. This is actually the main part. This is the only, I would say this is the only change that we need to do based on the last code that we've done. Now let's say our front is over here and the rear is pointing over here. Now what you need to do is, let's say you need to bring your rear. Now let's say you want to insert some elements. So what you do, you bring your rear over here. So you want to bring it over here. So how you can do it? I also told the size of this array. So the size of this array is going to be 4. And right now our rear is pointing towards 3. Okay. Now think about this. We need to somehow manipulate the value so that your rear currently pointing towards 3. That means 1 before the size of the array should come back to 0. Okay. And you should find some way so that this can, be like the same for all the other places. For example, your rear is like some other places and you want to bring them to 0, and then also to the next numbers as well, because we're going to be using a uniformed way to do it. Now you can pause this video and have a thought about how you can bring this 3, the rear pointing towards 3, towards 0. And let me reveal the answer. It's actually very simple. You're just going to do 3 plus 1 to make it 4, and then you're going to do a modulus of 4 that is the size of your array, and that would be 0. Now this formula will work mostly for everything, and you can use this as a most common formula for wrapping up your elements whenever you stand at any position. Let me show you. For example, let's say I'm standing at 0, 1, and 2. Let's say I'm standing at 1. Okay. Okay, yeah, the rear is standing over here, and now we're inserting an element. Now the rear is moving towards the index 2 because we're inserting something. Now this same formula can be applied over here as well. Even though you don't want to wrap it, even when you don't want the elements to wrap, this can help. So how we're going to do? We're going to do 1 plus 1. The size of the array would obviously be 3. And modulus of 3, so 2 modulus 3 would be 2. Okay, so you can use this as a universal formula for your finding a rear value whenever you want to, and it's going to always end up with the element you want your rear to be there. Now this is highly helpful when you're at the very end of your array, like the example we saw before, where we are at the very end and we really needed to go over here. This was super helpful because it did just what we wanted. So this is very simple. This is the past rear value, the current rear value that it's pointing to. This is just plus 1, which we're doing. And after this modulus is going to be the size of your array. Okay. So that's what we wrote over here, that we return rear plus 1 modulus of size equal to front. Now there might be some questions like, how would you know the Q is full just by seeing that rear plus 1 modulus of 4 equal to size? Oh, sorry, equal to front. So let's say 0, 1, 2, and 3. Okay. Right now, our element is our rear is over here, and our front is over here. So when your front is pointing towards the first element and your rear is pointing towards the last element in an array, we already know that the Q is full. Okay. So what we do here, we try to find the rear, and so we can just do a check like this. So we can simply do 3 plus 1 and modulus of 4, and that will lead us to 0, which means we are at the end of the, we are literally at the end. Okay, so there is no way you can go and insert an element again that is still on the queue. Okay, so you don't want that things to be happening over there. So that's why we do check if it is full or not using this condition, right? So let's keep on moving with our implementation. So we checked if it's full, if it's empty. Now it's time to do enqueue and dequeues as well. So we're going to do public void, and we're going to do an enqueue function. Now enqueue is to insert our element at the rear. Okay, so we're going to do a data, and now how do we do this enqueue? It's very simple. We first need to check if it's full. Okay, and then we will start inserting our element. Okay, so let's get started. So if it's full, we print something. Let me print Q is full. Yes, it is full, and I don't want this function to continue. Then we're going to check if it is empty or not. So if is empty, so if it's empty, we want to, if it is empty, we don't want our front and rear to be pointing to -1, which we've done over here, right? So we want both of them to be pointing towards equal to 0 and rear equal to 0. Okay. Then what we usually do is we do rear plus plus, and then we just store the value. So this is what we have done for our last Q video. This is what we have done. But from here onwards, whenever you're getting your mind into a circular queue, you shouldn't do this. Okay. What you should do, if you're doing plus plus, then once your array got full, once your rear is starting to point towards the very last end, it can't move towards 0. So what we saw already is what we're going to implement. So I'm going to do rear plus 1. So we want this operation to happen first, and then we do a modulus of your size of your array. Okay. Now this is how you do your enqueue function. And another thing that I want to do is next is a dequeue. Let's do a dequeue. Public int dequeue. So we do want to return our value whenever we are deleting. It returns the values. So we're doing a dequeue. And if it is empty, we can't delete an element, so if is empty, very simple, our front would be pointing towards -1, and we would just simply return. We can have a message to tell that Q is empty. All right, now what we're going to do, we're going to go ahead and we are going to check if there is only one element or not. Okay, now in DQ also you can perform whatever you performed in your rear element. In your NQ, you perform something, you can also perform it for your front. I'll tell you how and when to do that. So now, before removing the element, we need to store it into a value so that you can return that value, whatever you removed. So first we store the value that we want to remove, and removal starts from the front. So we're storing the front value. Or you could also print that value instead of returning, but we prefer returning. And what you can do now, if there is only one element, okay, I'm talking about only one element, which I'll quickly show you. So let's say our Q has only one element. So it has 1, 2, and 3, okay? The front was here, and the rear is here, because this is the first element that we inserted, and this is the last. Now I'm gonna delete the first in, first out. So first comes, goes, and front is gonna point here. Now this is also being deleted, so front is gonna point over here. Now you can see that both of them are pointing towards the same element, which means there's only one element left in the array. So if front is equal to rear, we can reset the values of the front and rear to -1, meaning that our Q is now completely empty. Now, what if there are many elements? Okay, you need to know that as well. And over here, I'm going to give an else condition, because after executing the if, this will be executed. And we don't want that to execute, because when rear is pointing towards 0, we want it to be pointing towards 0, the first element. When there is only one element, always remember, when there is only one element, front and rear would always have the same values. Okay, so when it is the first element, rear would be like 0 and front would be also 0 when it's the first element in the queue. But whenever you're trying to insert a lot of elements and then you start deleting your elements, and then you reach the end of the queue and there's only one element left, there too your front and rear would be the same. Your front and rear would be pointing towards the last element. So right now in the else condition, we are having this one where we do the rear part and then we insert a value. Now in the DQ part, you see over here, front is equal to rear. We set that back to front equal to -1 and rear equal to -1. Now, in the else condition, what if they are not at the same value? Imagine this situation, so you don't need to worry whenever in our normal queue, we will be doing front plus plus, but this is a circular queue. So we want all the behaviors to be in a circular manner. Instead of going just in a forward direction, we need everything to wrap up so that, you don't really get those exceptions going on. So basically over here, in a circular queue, whenever you delete an element, it is possible for you to add an element to that position back. So over here we have 10, 20, and 30. So we're going to stimulate that. I'm going to show you that, and you'll be clearly understanding why you need to perform the circular wrapping part in the rear as well as in the front. So for rear, we're doing it in the NQ. At the same time, you have to do it in the DQ as well. So I'm going to show you how. So let's say that over here we have deleted the 10 element, the front element, and the front moved here. And now we inserted another element 40, and we can't insert here because this is the size capacity. So now rear would be pointing towards here. And now we are going to delete this element as well. So front points towards here. And this just got deleted. So you can see that front is here and rear is here. Sorry for not writing the position. So rear is at 0th position and front is at the last position, which is 2. Let's say that this element is also deleted. Now during a normal front behavior, this would be like, nah. But now your front needs to come back here. If you want to delete this element, it needs to come back here. So the way that we already did is the same for front as well. So we will be doing front plus 1. And after that, we will be modulus with the size. So over here, the size of this array would be 4. Sorry, that would be, yeah, that would be 3. And when we come back over here, we need to do plus 1 and modulus of 4. So you can go back here and do the operations. And this also applies for the same. Let's say we are trying to insert another element. Let's say you insert 50, rear would go here. And let's say you want to like delete this element as well. So when you want to delete this element, your front would obviously move here. So now when you want to calculate this position, you can obviously do it with the same formula that you have here. Front would be currently 0, the past position, and plus 1. And the modulus of size is 4. So that will indicate the first position, which you are right now. So let's just quickly implement the else condition as well. So front is equal to front plus 1. And also don't forget that this concept is really important for you to perform your display as well. So you can't normally do your display like you did before. That also will have changes because you're wrapping it up. So you need to make sure that you also, make sure you also visit your other elements when your front and rear is pointing towards the back. Okay, let me just explain you that as well. So once we've done this one, it's time to do the display. So for the display, alright. So for the display, we will check if it's empty, and we will do system.out.println, and we will say our queue is our queue is empty, so you can't really display anything. Next, you will want to print your queue now. So you have to initialize it to front, and remember, whenever you're initializing it to front, it can be at any position. So here your front can be here, and your rear can be here. So how would you print it? You need to print it first 20, and then 30, and then 10. This is how you need to print it, because this is the first element, second, and this is the newly inserted element. whenever you're writing code, you need to be very, very systematic in your approach. Like many people usually think, okay, for this condition, I would do this. Like when front is equal to at 0 and rear is at like the end or at any position, I would just print it, and I would just do a separate code for the circular behavior. But you don't really have to do it because we have found a code for our circular behavior, so we know how you can bring your pointers back and print it. For example, in the for loop, we have an I that is initialized over here. We have like I, which is initialized over the front, and we move this I over here, okay? And once you reach the last element, I know you cannot print it. So what you do over here is you can have a check condition. I'm not telling that you don't need to have it, but what I'm being specifically talking about is you don't need to write like 2 to 3 logics just for these conditions are being there. So when I is here and still we haven't reached the rear, then you can bring this I back to here. And how you can do that is very simple. You can do this by using our same old stuff which we've been talking, I plus 1 modulus of size. Okay, so I'm gonna do this for you guys. So we're gonna use a while loop over here. So inside the while loop, I'm gonna keep on printing it. So now what I'm gonna do is, well, like it's true, I'm going to say, okay, you're true. So right now, just print the element because we have pointed it to the front. So, so print the element. And another thing, not println, just print it. Now, another thing that you need to make sure that you do before you're doing I is equal to I plus 1 modulus of size, you need to make sure if I is equal to rear, then you're going to break the loop. That means you have reached the end. Okay. Sometimes your rear can be 0, as we already saw here. That if it is like the very first element, your front would be pointing to 0 and rear would also be pointing to 0. So at that time, you just need to break it whenever your I is equal to 0 or rear, or the rear can be any values. But whatever if your I is pointing towards the rear, then that is your last element, and you want to make sure that you break it so that it doesn't continue. And then we will do I plus 1 modulus of size. So yeah. Okay, so it's integer, so I'm gonna do a -1. Oh, you're missing a return statement. Oh yeah, this should return the value. This is a deque function. So we're going to return, I'm so sorry, we're going to return a value. All right, our code is running good. Just a few misses, but other than that, it's good. So now we created our queue, and we need to insert elements. So we're inserting 10, 20, 30, 40, and 50. And then we're doing a deque, and I'm printing out all the deques that I've done. So the deque is happening from here, which is we're doing a deque, like 3 deques, and then you're inserting values like 60 and 70, I think we've done a mistake. I mean, we've done an error. You can see the DQ value is 0, but it's not. And then you can see over here that we got 6 instead of like 5 values. Like, I mean, what did we do wrong? Okay, I found the error, but I'm honestly sorry. I shouldn't add this one, but okay. So 0 is the first element, but after if we're not inserting anything into the real values, so let me run it again. So right now you can see we have removed 10, 20, and 30, and we have 40, 50, but next our values should be 60 and 70. But what we're doing is actually we're displaying it. So 40 and 50 is getting displayed. And then when we enqueue 60 and 70, it's again getting displayed. So we didn't include a bit of free space in it. So println, yeah, so this would obviously give us a bit more space. All right. All right, so here's a good one. So yeah, so all great. I think everything is correct. Not I think, like, it's absolutely correct. So you can like follow this video, I would say. And thanks for watching. I know that was a bit of mistakes, but I think they're like very minute. And I hope if you guys really know arrays well, then this won't be a problem. So thank you for watching.